Can some ice turn your MacBook Air into a MacBook Pro? Let me explain. Welcome back to the channel. So I have a fun one today, really fun actually. I'm going to actually see if some ice here can give my MacBook Air over here better performance on an export test with video editing, all right? Now, this test isn't going to be scientific. It's actually going to get all of the testing police's panties in a bunch, as you know. They love to do that. I'm sure I'm going to get comments, all the things I screwed up. So before I get into the actual video and show you how I'm going to do this, a couple kind of disclaimers. All right, number one, don't do this at home. Don't test this on your MacBook. I'm testing it for you. It's a fun video. I'm going to be putting this on some ice cubes to see if it actually can make the performance better when I'm doing the export. You don't do this. It might make condensation when it touches the metal, the ice touching the metal. I'm going to do some precautionary things. I'm going to put a layer of paper towels on this. But overall, just don't do this at home. And then number two, this is a test out of millions. I'm just doing an export test using CapCut, the video editing software. I'm going to have a 15-minute timeline. All these different factors are built into this one specific test, so all tests will be different. This is just one. I have no idea what's going to happen. I just want to lay out the facts that this is 1 in a million tests, so, you know, there's never a right or wrong one. This is just one of them. Okay, let's have some fun now. Now, a little while back, if you watch Luke Manani's channel, he basically did a test on the M1 MacBook Air maybe a year or two ago, where he actually took off the back and he put thermal tape right on top of the CPU, all right? He was able to get better performance. He tested it. It was better performance. He proved it, all right? But let me see this guy's name. It was Arthur Weiner. I believe it's Arthur, W-I-N-E-R. He created a video and it says, the name of the title of his video was, I killed my M2 MacBook Air following Linus and MaxTech's tips, all right? So Linus, and also Linus, you know Linus, right? And then also MaxTech tried the same thing and it worked. It gave him better performance. But this guy's saying that he ended up killing his MacBook. If you watch his video, he's a great channel. He didn't kill it, but he wanted to kind of point out a couple things. What he basically did is when you put that thermal pad on the CPU, it touches the back plate, the actual back of the laptop back here, right? In the back. And what it does is it dissipates that heat across there. Now, the problem with this is the heat is supposed to be concentrated around the CPU, and that's what these things are made for. What happened with his is when you put the thermal pad on there, what happens is it dissipates the heat and it touches more of the battery because the heat comes out and makes the backplate hotter, and that goes over the battery. So overall, your battery lasts a lot less, all right? So it's going to kill your battery over time, and that's what he was saying in that video. So long story short, those things might work, but don't do them because Apple's a really smart engineering company and they did all these tests just to make sure that things won't break later on. And that was one thing that made it break, obviously, is when you heat the whole thing up, you actually put heat on the battery, and that's not really good. So they kind of do a good mix there, and that's kind of why they do what they do. All right, so my test is going to be a little different. I have these they're little blocks of ice. See them here? So I figured I'm going to go ahead and get some paper towels. I don't want this touching my back plate, making it too cold because condensation will form inside the MacBook. So I put a couple of these little paper towels over this, and I got it down to about 40-something degrees on here, all right? So it's really cool. And then I'm going to put the laptop on here, and I'm going to test it that way. This way I feel like the coolness is going to go over the entire laptop. I'm not just taking the heat from the actual CPU and moving it over to the battery, but I'm kind of cooling everything. I don't know. I'm just going to test this and see if it works. It's a fun test again. Don't come after me. I just figured, what in the world, what do I got to lose? All right, so let's set up the test of what I'm going to be doing here. So I have a video over here on CapCut, and I'll show you some close-ups of it. It's basically multi-layers of 4K with some sound in here. I think up to 3 layers of 4K. If I scroll over, you'll see some layers over here. I got a bunch of color grades in here. I also got a lot of transitions and text and stuff. It's a normal edit for me, right? So that's going to be my typical edit. It's 15 minutes long, and I'm going to go ahead and export this in CapCut. So what I'm going to do, though, is I'm going to do 4 different tests here, and then I'm going to come back and give you the results. So I'm going to do a test. First, do the export, and then get the time for the export with no ice, all right? No ice on it, just leave it alone, right? I'm going to get that test, write it down. Then I'm going to do another test right after that, just so that the laptop's now heated up, and see if that's slower than the first test and how much time does it take? Does it get longer because of the heat and stuff like that? Still no ice. And the next 2 tests are going to both have ice. So I'm going to put the ice down, put those towels over it, and then I'm going to go ahead and run the first test to see if it's any different than the no ice test, and then I'm going to run the second one and see if the second one actually is better than the second one with the no ice. So, obviously, actually, is it going to be able to keep the throttling down because it keeps it cool through the whole process? When I do 2 tests like that, especially 15 minutes each, it's going to give it enough time, almost 30 minutes of rendering, or I guess exporting, that's going to heat this thing up. So I don't know what the ice is going to do. Is it going to keep it cooled enough so it doesn't throttle? Is it going to make it less time to actually export? We'll find out, and let's start the test here now. All right, so let's run the first test. This is going to be the kind of the baseline, all right? I'm going to run the CapCut export right now. It's a 15-minute video, and I'm going to, with no ice or nothing like that, I'm just going to run it straight just like it normally would and see what the baseline is right away, and we'll come back and report back. All right, so I'm back. It took 14 minutes and 9 seconds to render the 15-minute video in 4K coming out of CapCut, so a little bit less than real time. 14 minutes and 9 seconds on that. Now the second test is going to have no ice as well, but I'm going to stop really quickly here and run it again while it's still hot. It's actually a little warm to the touch right now, so I'm going to go ahead and run it right away and see what happens here. So stay tuned for this, and I'll come right back. All right. Yeah, the heat did something. So I was watching it kind of an activity monitor, and I could see some spikes on the CPU. It still was very low, which is peculiar. It was using like 15% of my CPU the entire time, even when it got really hot. But overall, the second test was 17 minutes and 16 seconds. So the first test with no ice, 14 minutes and 9 seconds. The second test was 17 minutes and 16 seconds. So because it heated up and I did this consecutive test of 15 minutes, that went up, I think, 23% longer it took to actually render it the second time than the first time because of the heat. So now what I'm going to do is I'm going to come back in a little bit, but I'm going to wait an hour, let everything cool down, make sure this thing is not hot in any sense, shut it down, and then come back to you guys, and then I'm going to run it with the ice. All right, so we're back now. Now I ran it, the first test with the ice. So I put the ice down. I actually put a couple paper towels over it, just like, on top of this ice so it wouldn't be condensation, but still really cool to the touch. I put the laptop on the ice just like this, and I ran the test. So it was basically weighted down on the ice, and it's feeling that cold air coming up. Now, what happened is kind of peculiar is I felt the laptop during the test as well, and I watched kind of the activity monitor. This time it didn't jump at all, and the actual front of it stayed really cool. Like I didn't feel the same heat when I touched the front metal over here. So that was peculiar. It was definitely doing something. But the report came back at 13 minutes and 58 seconds for the first test, all right? So I got to hurry up and do the second test here in a second. 13 minutes and 58 seconds. The first one with no ice only took 14:09. So that's a 2%, like a 1.2% difference. So it really made no difference really on the first test. But it's just starting to get hot, so it might make more of a difference on the second test, I'm not sure. On the first test though, it might even been error, but it's about 1.2% quicker with the ice, I guess, or it takes 1.2% longer without the ice, whatever it's worth. But that's basically what the ice did in the first one, so not really a huge difference. All right, I can't actually believe this. So I ran the second test, and like I told you, the computer was not, it was not getting hot like it was before. I put this thing with the paper towels on this ice like this and ran the test. The second test consecutively for 15 minutes, so it's really a 30-minute test when I do both of them together. The second test came in at 13 minutes and 56 seconds. Faster than the first test, mind you, right? Faster than the first test, I don't know why. Maybe it got colder over time. 13:56. Now, remember this. The second test with no ice was 17 minutes and 16 seconds. The second test with the ice was 13 minutes and 56 seconds. So it actually got it's basically 24% slower without putting ice underneath it than with the ice when I do a 30-minute export, roughly, two of them, 250 minutes consecutively. That's pretty crazy, right? So 24% kind of, it takes 24% longer if I don't use the ice. What does that tell us? It's pretty crazy, right? So I don't know what to think of this, right? I mean, it's obviously a huge, it made it into a MacBook Pro, right? It really did some big differences here as far as the export times. Now, taking a step back, would I do this? Would this be a feasible thing to do? Put these things in the freezer, and when you want to do an export, take it out, put a couple paper towels on it over here. My chair creaks every time I do that, just like this, and then put my laptop right on top of that like that and run the test. I mean, I think if you are a bit crazy or, those type of things, it might be a good idea to do that, all right? But I wouldn't do it. So overall, it's not really worth the challenge or even the risk of breaking your MacBook because of the condensation. Obviously, I have this over top of it, so I'm not like completely, freezing it out. I wanted to make sure it was a reasonable temperature. But overall, I just don't think over time, I don't know what the condensation inside the unit's going to do to my laptop. I'm taking a chance because I have a channel. I don't think you should. That's number one. That percentage was obviously 24% 4% is huge, after 30 minutes. But really, after 30 minutes, you're saving what, a couple, like 4 minutes or something, 3 minutes, not even 3.5 minutes, somewhere in that range. So is it really worth that to risk the hardware? I don't think so. The other method of actually putting the tape also on the actual CPU, like they had mentioned before, that's not worth it either, because then your battery is a lot shorter life, and it might only last half as long as the full battery length. So we don't know what it's going to do to the internals. I mean, they're not made for being that cold. Maybe, I have no idea. At the end of the day, it was interesting, right? I mean, to see the difference there was pretty crazy. I mean, obviously, my kind of best bet would be go get one of those kind of laptop fans, the coolers that don't use ice, that blow up cold air through the actual, you stick it on kind of a stand, and then it blows up the cold air and it kind of cools your laptop. I think that might be your best bet, kind of in between the two, and it's not going to harm anything just because it's air. I don't know if that's going to get cold enough like this ice did, though. This ice was, really nice, and with this kind of over it, it maybe stayed at like 40-something degrees. I don't know if the cooler is going to be that good. So, you got to take that with a grain of salt. But you could see the performance differences here. They were pretty big, actually. Not in the first test because it didn't get, didn't have enough heat to get into thermal throttling. I think at the second test I did, it started to get a little hotter, and then it kind of cooled it off. I don't know. One test again in a million problems with this test, could break things and everything else. And so I know that the police out there are going to come and tell me that I shouldn't be doing this. But at the end of the day, you guys get the idea. It's all for fun, right? Tell me your thoughts. What could I do differently? What could be a better test? Maybe I'll do it. Maybe I won't. And we'll talk to you in the next one. Peace.